Welcome to the class. Today we are going to discuss application of LCM and HCF. Let us see LCM first. So there is one application of LCM, that is LCM with remainders. So what is the case 1 here? In case 1, when the remainders are same for all divisors. Let us see one example here first, then we will go to the question. So the question here is, if there is a number x, when we divide this number with 3 or 4 or 5, we need to get the remainder as 0. Okay. So what is the least possible number when we divide with 3, 4, 5, where we will get the remainder as 0? That is the question, right? Now, when will we get the remainder 0? For all the three numbers, the number should be same. Means it should be a common multiple of 3, 4, 5. So it is nothing but we need to find out the LCM of 3, 4 and 5. What is the LCM of 3, 4 and 5? 60. So 60 is the multiple where we have a common multiple for 3, 4 and 5. So 60 is the least possible number where we will get the remainder as 0. Now what will be the second number where we will get the remainder as 0? That will be the 60 multiple, that is 120. What is the third number? It will be the 180. Now these are the common multiples of 3, 4, 5. Since we want the least, the answer is 60. If we ask you what is the third least number, that is 180. If we ask you what will be the highest 3-digit number, we'll see which is one is nearest to 999, that is the multiple of 3, 4, 5. That will be our answer. Okay. Now let us see same example. Now find out the least possible number when we divide with 3, 4, 5. It leaves the remainder as 1. Previously, I want the remainder as 0, but I want remainder as 1 when you divide the number with 3, 4, 5. So, what is our answer? LCM of 3, 4, 5. So, this will give the remainder 0. Since I want 1, we will add plus 1 here. So, what is the answer? 60 plus 1, 61. Hope you have understood this. Okay. Now, if you observe, the question given here is same model, but the numbers are different. Let us apply the same concept for the above question. Okay. So, what is the least possible number which, when divided by 24, 32 and 42, in each case it leaves the remainder 5. So, what we need to do? Just find out the LCM of 24, 32 and 42 and add 5 to it. So let us find out the LCM of 24, 32 and 42. 24 can be written as 2 into 2 into 2 into 3. 32 can be written as 2 cube is 8. 2 square is 4. So 2 power 5. And 42 can be written as, so 2 into 7 into 3. So what is the LCM? So do you remember the concept I have discussed? We will take all the prime numbers with highest degree for LCM. So what are the prime numbers here? 2, 3 and 7. What is the highest degree of 7? 1. Into what is the highest degree of 3? 1. But what is the highest degree of 2? 2 power 5. So 2 power 5 is 32. 32 into 3 into 7. So 32 into 3 it is 96. 96 into 7. 7 19, 630, 7 6 42. So it will be 630 plus 42. 672 is the LCM. Since I want remainder as 5, the answer will be 672 plus 5, which is nothing but 677. Okay. Now let's see case 2. When the remainders are different for all divisors, but the respective difference between the divisors and remainders is constant. Okay, so there is one number. Let us say there is one number x. So if you observe the question, what is the question here? We need to find out the least possible number when we divide with 2, 3, 4, 5, 6. It leaves the remainders 1, 2, 3, 4, 5 respectively. Means if you divide this number with 2, I need to get the remainder as 1. If you divide the same number with 3, I need to get the remainder as 2. If you divide the same number with 4, I need to get the remainder as 3. Like that it was given. Right? Now, before these remainders, where I will get the remainder 0 for the multiples of 2, 3, 4, 5, 6. So, it will be a common multiple. So, let us find out LCM first. So, what is the LCM of 2, 3, 4, 5 and 6? So, here again if you see, what is the multiples, common multiple where we'll get for 2, 3, 4, 5, 6, that is at 60 again. So LCM of these numbers is 60. But here the remainder is not same. If the remainder is same, I would have added the same number here so that I will get the remainder for every divisor same. But here the remainders are different. Now, for this concept, just see here, when the remainders are different, but the respective difference between divisor and remainder is constant. Means what is the meaning? What is the divisor? 2 and what is the remainder? I need to get it. Divisor 2, 1. What is the divisor? Next divisor 3. Remainder 2. Next divisor is 4. Remainder is 3. Next divisor is 5. And the remainder is 4. Next divisor is 6. And the remainder is 5. But if you observe, what is the difference between divisor and remainder? 1, 1, 1, 1. So it is constant. If this case occurs, just we need to do is find out the LCM of divisors and subtract the difference between divisor and remainder, but it should be constant. So what is the answer? So LCM I got 60 and difference is 1. So the answer will be 59. If you want, you can check. If you divide 59 with 2, you will get remainder as 1. If you divide 59 with 3, you will get remainder as 2. Like that, it will continue. Hope you have understood case 2. Now let us move to the case 3. So what is case 3? What is the least possible number which when divided by 13 leaves the remainder 3, and when it is divided by 5 it should leave the remainder as 2. So here divisors are different as well as remainders. Again it is looking like same as case 2. Now let us see whether we have the same difference for both divisor and remainders. So if you divide a number with 3, I need to get the remainder as 3. If you divide the number with 5, I need to get the remainder as 2. But if you observe, the difference is 10 here, and when it is divided by 5, remainder is 2. But what is difference here? 3. So here it is not like case 2 because the difference between divisor and remainder at both the numbers are different. So at this place, what we need to do, let's see. Now, if you see in this case, the divisor and remainder are different, right? Now, let us say there is one number which is exactly divisible by 13. So it will be in which form? 13x. Since I want the remainder as 3 here, I will add 3. So this is the number I need. Okay, so my number will be definitely in which form? That is 13x plus 3. But if you divide this number with 5, what I need to get the remainder it is given in the question? The remainder should be. So here we need to check the possibility. Okay, so let us say if you take this x as one integer, that is, you can check with the integers and we can find out the answer. That is one method. In the place of x, start doing checking the integers here. Let us take 1. 13 into 1, 13 plus 3, 16. 16 by 5. I am getting remainder as 1, but I want remainder as 2. Like that, where I will get the remainder as 2, that will be the x value. Okay. But if we check like that, we will be late. I'll tell you one method here. Let us divide this 13x plus 3 in the multiples of 5. So, from 13x, I will take 10x out. So, 10x by 5. This is the remainder where I will get 0. But I don't want remainder 0, I want remainder 2. So what is the leftover? That is 2x, sorry, 3x plus 3. So I want the number which is divided by 5. That is in the form of 3x plus 3, where I will get the remainder as 2. Now, this will be somewhat easier than the previous one, right? Now, let us keep x value as 1. 3 into 1, 3 plus 3, 6 by 5? No. So, 3 into 2, 6 plus 3, 9. Will I get 9 divided by 5 remainder 2? No. Now, 3 into 3, 6, 9 plus 3, 12 by 5. S. If I keep x value as 3, I am getting remainder as 2. So, then what is definitely my answer? It will be the 13 into 3 plus 3. Because the number will be in 13x plus 3 form, right? Now, 13 3s are 39 plus 3, 42. So, 42 is the least possible number. When you divide with 13, it will give remainder 3. When you divide with 5, it will give the remainder as 2. Hope we have understood this cases of LCM. Now, let us see what are the cases of HCF with. Let's see application of HCF, that is HCF with remainders. Case 1, when remainders are same. So, we need to find out a number with which when we divide 60 and 98, it should give the remainder 3 in each case. Now, let us take an example here. So, before remainder 3, I will check with remainder 0. So there is a number 60. When I divide with x, I need to get the remainder as 0. And there is one more number 88. And when I divide with the same number x, I need to get the remainder as 0. So here I need to find such number which is a common factor of 60 and 98. That is common divisor of 60 and 98, where I will get remainder 0. So it is nothing but we have so many common factors for 60 and 98, but here I need to find out the greatest. Means it is nothing but we need to find out the HCF of 60 and 98. Now let us find out the HCF of 60 and 98. So what is the largest number? 98, and divide with 60. 60 one time, 60, remainder is 38. Again 60 will come here one time, 38. Remainder is 22, 38 one time, 22 one time, 22, and the remainder is 16. Again 22 here, one time 16, remainder is 6. Again 16 will come here, 6 2s are 12, remainder is 4. Again 6, 4 1s are 4, remainder is 2, and 4, 2 times 4, remainder 0. So at which divisor I got remainder as 0? 2. So the HCF of 60 and 98 is 2. So what is the greatest possible number where I can divide 60 and 98 with these two will get remainder 0? Sorry. What is the greatest common number which will divide 60 and 98 and gives remainder 0? That is 2. Okay. But here I don't want the remainder as 0. I want the remainder as 3 in each case. So what you will do? 60 subtract the remainder which you need to get from the number. That is 60 minus 3. Then I will get the remainder as 3. And here also 98 minus 3 by x. I will get the remainder 3. Now 60 minus 3 means 57 and 98 minus 3 95. Now find out the HCF of 57 and 95. That will be our answer. So what is the HCF of 57 and 95? What is the largest number? 95. 57 one time 57. So what is the remainder? 33, 38 and 57. 38 one time 38. What is the remainder? 19. And here it will be 38, 19 twos, 38, and the remainder is 0. So at which divisor I got remainder 0? 19. So what is the answer? 19. So 19 is the greatest possible number. When I divide 60 and 98 with this 19, it will give the remainder as 3 in each case. If you want, you can check 60 divided by 19. 19 3 is 57, remainder 3. And what is one more number? 98 divided by 19. 19 5 times. 95, remainder is 3. Now let's see case 2. When remainders are different. So here we need to find out the greatest possible number with which when we divide 37 and 58, it should leave the remainder 2 and 3 respectively. So when remainders are different, what we need to do? Just it is like same above, but since the remainders are different, subtract the respective remainders from the respective numbers. 39 minus 2, what is the number? 35. And what is one more number? 58 minus 3, 55. Now find out the HCF of 35 and 55. So what is the largest? 55. So divide with 35 one time, 35, remainder is 20, and here it will be 35 one time, 20, 15 will be the divisor now, and 20, 15 months, 15, remainder is 5, 15, 5 threes are 15, remainder is 0. So which divisor I got? At 5. So what is the HCF of 35 and 55? 5. So what is our answer? 5. So 5 is the greatest possible number. If you divide 37 with 5, it will give remainder 2. If you divide 58 with 5, it will give the remainder as 3. If you want, you can check. 37 divided by 5. 5 sevens are 35, remainder is 2. You can check 58 also. 58 divided by 5. 5 11s are 55. What is the remainder? Okay. Now let's see the third case. So what is case 3? When remainders are same, but the value of remainder is unknown. So remember, for this we have one formula. Whenever you see this type of questions, just remember, find out the HCF of, let us say there are 3 or more than 3 numbers given. Just take the difference of consecutive numbers. Let us say 3 numbers are A, B, C. Find out the difference of A minus B and B minus C and C minus A. Since I am saying difference, it should be positive. So let us consider first number A, second number B, third number C. Now do the HCF for the differences. So what is the difference between 38 and 66? 22 plus 6, 28. And 66 and 18, 14. And 18 and 38, 40. So this will be your answer. So clearly you can see that 14 will divide 28 and 42. So definitely 14 is the HCF, that is common factor here. So the HCF of 28, 14 and 42 is 14. So 14 is the greatest possible number. When you divide 38, 66 and 80, it will leave the same remainder. If you want, you can check 38 by 14. What is the remainder? 14 twos are 28. Remainder is 10. 66 by 14. 14 fours are 56. Remainder is 10. 80 by 14. 14 fives are 70. Remainder is 10. So what is the answer for case 3? 14 will be the answer. Hope you have understood the concept of LCM and HCF. Thank you everyone.